Hey, this is Jason Clark here at South Dakota State University, and today we're going to be going over the fertilizer recommendation for nitrogen for our sunflower crop. Let's get started. So our recommendation starts out with our yield goal. We're going to multiply that by a coefficient of 0.05, subtract our soil test nitrogen, subtract our LC, which is a legume credit, and then add a no-till debit. And we're going to talk about each of these things in turn. So first of all, we're going to talk about yield goal. A lot of times with yield goals, we think about goals. We think of what we want to obtain in the future. So, a goal might be 4,000 pounds per acre. That's a goal we want to obtain in the future. However, what we might actually be able to produce in the field is closer to 1,200 pounds per acre. So with the yield goal, it's not saying necessarily what we want to obtain, but which is realistic. What yield potential can we realistically obtain in this field? So there are several ways to do this, but I'm going to go through one way of how we're going to calculate our realistic yield goal. The first step is we want to gather 6 to 10 years of yield data. And once we've done that, what I normally do is go ahead and put it in a spreadsheet. And we're going to have that yield data going down by years. And then step number 2 is we're going to identify our low and high value. So here in 2015, we had low value of 1,500 pounds per acre of yield. And then in 2012, we had a relatively higher yielding, 2060, which both of those, I would say one is below normal, one is above normal. So to kind of average things out better, we're going to delete those two values. And then the next step is we're going to average those remaining yields. So we take the average of the remaining 8 years that we have, and if we end up with 1,790 pounds per acre for our sunflower yield. And then after that, what we want to do is we're going to increase or decrease this by 6 to 10%. We can use the default that on average we're increasing our yield level by about 6% each year. So we're going to increase that, use that increment. Or there's another thing that we can do, and that is using soil moisture. If our soil is at fill capacity and it's going to help that seed germinate quickly, we might want to increase that by 6 to 10%. However, if we're looking at planting that sunflower into dry seed conditions, and which might decrease yield overall, we might decrease that yield goal by 6 to 10%. And if we did each of those, this is what those numbers look like right here. So overall, if we increase it, it'd be about 1,800 pounds per acre. If we decrease it, it'd be around 1,600 pounds per acre. That would be our yield goal for that time. So here's a quick synopsis of these 4 steps that we can look at. We're going to gather that data. We're going to delete the high and low values. We're going to average those remaining yields. And we're going to increase it or decrease it by 6 to 10%. So we had our first step here in our yield goal nitrogen fertilizer recommendation tool. We determined our yield goal around 1,800 pounds per acre. Next thing we're going to do is we're going to multiply that by a coefficient. That coefficient is 0.05. So the question is, where does that 0.05 come from? Well, let's find out really quickly here. So first of all, to determine this coefficient, we take our soil test values for our nitrogen in that top 2 feet, and we take our fertilizer nitrogen rate required to optimize yield for our sunflower crop, and we add those things together. So say, for example, added up to 75 pounds of nitrogen per acre. Then we're going to take that and divide that by our yield that we obtain, and we're going to say 1,500 pounds per acre in this example. And we do our math, and we say that it took 0.05 pounds of nitrogen to produce each pound of sunflower yield. So that's where that 0.05 number comes from. So we take that, we multiply it by 0.05, and in this case we get 95 pounds of nitrogen per acre. However, we have an asterisk there, so we need to understand what that asterisk is. And this is that component where we're looking at minimizing that potential for disease as well as lodging. So if this value is above 150 pounds of nitrogen per acre, we're going to reduce it to 150. So we take that recommendation, and next we're going to look at our soil test end, and this is a really important part of this recommendation. So we're going to go out into the field here. We're going to take our soil probe, we're going to go out, and we're going to take a soil sample. If we notice, the white dots represent our nitrogen fertilizer in our soil. So we're going to first of all take that 0 to 6 inch depth, and this is going to be for organic matter, phosphorus, potassium, sulfur, that's standard measurement. However, we still have a bunch of nitrogen potentially in that soil that sunflower can get to. So we're going to go down deeper. We're going to get that 6 to 24 inch soil depth, and we're going to look at that as well. And so see, there's still more nitrogen in the soil, and if we have the equipment, we can go deeper and have a better assessment of what's available to that sunflower crop. since it can go down 3 or 4 feet and still get nitrogen. So we're going to take those soil samples, separate them out, mix them well together, and send them to the lab to get our analysis that we can see here, and then convert that to pounds of nitrogen per acre and add up that 8 pounds plus 12 pounds. We're going to say in this field we had 20 pounds of nitrogen per acre in that top 2 feet that we're going to use in our equation. So we have our soil test values here, and we subtract that 20 feet, and we end up with 75 pounds of nitrogen per acre. Our next step in the equation is our legume credit. Our legumes we're concerned about is our soybean, our alfalfa, any clovers or anything like that we planted before we are planting our sunflower seeds. And the reason we have this recommendation is it's all about that carbon-nitrogen ratio of how much is in that plant residue before it starts providing nitrogen to our sunflower crop. So if we look here really quickly at this graph, we can see different carbon-nitrogen ratios. The higher it is, the more carbon. The lower it is, the less carbon there is and more nitrogen. So if we're up here towards the 60 to 30 range here, this is where we're immobilizing nitrogen. We're taking nitrogen from the system, from the soil, and microbes are using it to break down that previous crop residue. However, once we get to that 20 to 30 range, it's about a 1-to-1 reaction. For every unit of nitrogen the microbes take out, the microbes are also inputting a unit of nitrogen. But it's really below that point where we're getting mineralization, where that green line is, and we're actually starting to feed that next crop from our previous crop. So we're giving nitrogen to the field. So the time from this point to this point is where we're really concerned about, to that green line. We want that green line right here to really match up with the timing that that sunflower needs to take up nitrogen, and that will reduce the amount of nitrogen we need to apply. So if we look at some of our previous crops where they planted corn, soybean, wheat, or alfalfa, we see that the soybean and alfalfa, our legume crops, are much lower on that carbon to nitrogen ratio, which means they're going to get to this point over here past the green line of net mineralization, which is what we want, faster. So that's why they have a credit. So if we look at this table here, we can see the different credits. If we grow after soybean, we're going to get a 40-pound credit. If it's after alfalfa or green manure crop or clover, it depends on the amount of plants per square foot that remain before we go into sunflower, and you can see those credits here. So if in this example we're going to say we planted a legume before our sunflower, and it's going to be a credit of 40 pounds per acre. So now our recommendation is 35 pounds of nitrogen per acre. So next, the last part of our equation, we're going to look at that no-till debit. So this is research that was done in South Dakota before I arrived here, and it looked at conventional tillage moving over to no-till, and it found that in general we need about 30 more pounds of nitrogen per acre to produce a crop. And in North Dakota they found a similar instance. However, they looked at about 20 pounds of N per acre. But a caveat in North Dakota is what they've seen is after about 6+ years of no-till, it actually turns around and starts being a credit of nitrogen to that crop, so we can actually reduce that recommendation. So the question is here, what about in South Dakota? Do we have that credit? Well, that's what we're currently working on right now, to see how many years past the beginning of no-till can we actually start to lessen that nitrogen fertilization rate. So if we look here and we go back and we say we're in no-till, and we're going to add that 30-pound debit to that equation, we're going to do our math here, and we're going to get about 65 pounds of nitrogen per acre, and say we're putting on urea, which is 46% nitrogen. Do our math, and we're going to say it's about 141 pounds of urea per acre that we're going to apply to our sunflower crops this past year. So that's our fertilizer recommendation. Another question we have a lot with nitrogen recommendations is, what about split nitrogen recommendations? What about using inhibitors to limit volatilization or denitrification or things like that? So one study that was done in South Dakota is we looked at single nitrogen applications versus a split application, and what we found is yields were similar. So a couple of situations that were evaluated were a single nitrogen application or a split where we applied 50% at planting and 50% at that V4R1 stage, had similar yields. And another one we looked at single nitrogen application or a single nitrogen application with a urease inhibitor or a split N. Again, similar yields. Thank you for joining us today, and as always, feel free to contact us and follow us on our social media outlets for more up-to-date information on soil fertility for crops in South Dakota.